Welcome and hello. This is a support video in HEC-RAS, which I'm titling Initializing River Flow in a 2D Model. So I got a question from a viewer in a different video, and it asks, paraphrased, the majority of our rivers continue to flow even without runoff due to base flow. Is there a way to include this in our HEC-RAS models so that they don't start dry? And the answer is yes. The short answer is to set a warm-up period. So what I'm going to do in this lesson is demonstrate how to do that specifically in a 2D model. All right, what you're seeing on the screen here is my results, the depth results in RAS Mapper. I'm going to go ahead and roll back the animation. And what you may have noticed is at the very first time step, I have a completely dry riverbed. Here is the terrain. The flow is in this downstream direction. And if I zoom out a little bit here, let's go ahead and start the animation. We see the water. This is a 5-minute time step. It just slowly flowing down the river channel. And then that is not what we want. So let me toggle off the terrain. This is an hour 30 into the simulation. It looks like it's almost to the bottom. Let's just finish things up here. So there's hour 40, hour 50, 2 hours, 210, 220, 230. So we could just say about 3 hours. That's where this simulation ends. Before we make the change, let's do a few things. First, I want to show you what the model is. So after importing the terrain and modifying the mesh with a break line down the center, I just have that toggled off. Then I defined the flow data. So I went up to edit and then unsteady flow data. I have a boundary condition for upstream, which is the flow hydrograph with a 1-day time step. I'm using 5,000 CFS, but you could change it to whatever base flow you want to use. Another option would be to use the stage hydrograph for your upstream boundary condition. And then, based on a rating curve, you would know what that flow rate is. And then for the downstream boundary condition, I'm just using normal depth. I set it to a modest 0.2%. Let's go back and check out some of these depths. So down towards the very downstream end of our reach, if I click on depth, this is the problem that we're trying to solve. We have a depth of 0 feet for the first 2.5 days or so. And then finally, we get a little bit of depth to 3 feet by the end of the third day. All right, let's go and check out a location further towards the upstream end of our reach. How about right here? Let's go right click, plot the time series, click on depth. And here it takes about probably 8 or 10 hours for the water to reach this location. And then when it does, after 3 days, it's up to about 8 feet of depth. So depending on what you want to set for your initial water depth, you can control that a few different ways, such as through the boundary conditions. But what we want to do is start our simulation at time 0, which is right here. And we want that to start blue. We want some water in our river at the beginning of the simulation. So to do that, you're going to set a warm-up period. Again, this is in 2D. So to do that, you're going to go up to the Run menu, Unsteady Flow Analysis. When this dialog box pops up, you want to click on Options and then Computation Options and Tolerances. And then this dialog box pops up. For 2D flow, you want to click on this tab, 2D flow options, and then initial conditions time in hours. This is the duration of time you want the model to run in warm up. So in our case, the depth of flow would be properly initialized for when we want the simulation to start. So I'm using HEC-RAS version 6.6. If you're using a different version of HEC-RAS, this initial condition time in hours might not be row 11. In previous versions, it was a little bit higher up on this list. But anyway, what you're looking for is initial conditions time. I'm going to just say 3 hours and then 3 hours. This is for default. And then the perimeter 1 is the name of my perimeter for my 2D flow area that I'm using. For the next row down, I'm just going to leave that as the default value, the initial condition ramp up fraction of 0.1. So that's fine. Let's go ahead and run the model and see what happens. So let me file, save that plan. It's going to run for 3 hours, but it's going to start with a 3-hour warm-up period before the 3-hour simulation. Okay, so click on compute. This right here is the warm-up period. See, it's counting down. Okay, now this is the actual simulation and it was counting up and then we're done. So click on close. Let's also close this. I'm going to click on the results for depth and then come here and cool. So we have water in our reach in our 2D model for a time period starting at 0 hours. So if I click the play button now to animate this simulation, it's probably going to look close to the same the entire time. Here's the play button. Okay, So there's half an hour. There's 1 hour right there. That's 2 hours and 2.5 hours. Pretty much the same shade of blue, which means it's probably pretty much the same shade of same depth for the entire 3 hours. Let's do one check here. Towards the downstream end, I'm just going to go right click and then plot the depth. So it starts at about what, 3.5 something, 3.6. It ends at about 4.6. What's important is that it starts at a non-zero depth, and then further upstream, let's make one more check. How about right here again? I'll go right click, plot the depth versus time. Starts at about 8.5, ends at about 8.9, 8.85 or so. All right. So there's other things you can do to modify this. Of course, your downstream boundary conditions, your upstream boundary conditions. But in general, the primary answer to the question is to use a warm-up period for your model when you're trying to start the simulation with your rivers fully flowing based on the base flow.